Hello dear students, I welcome all of you for today's video regarding catalysis process. It is one of the catalysis subtopic which comes under surface chemistry part. So when you consider catalysis, we need to understand the first definition. What do you mean by catalysis process? A chemical reaction which is carried out in presence of catalyst is referred as catalyst used reaction. Whenever we consider catalyst particularly, these are the substances which enhances the chemical reactions rate, or it may decreases the rate of the reaction. That means there will be a change in chemical reaction by involving the catalyst, and that catalyst which is involved in the chemical reaction doesn't alter in its mass or in its chemical property, and it will be performing rate of reaction it will be forwarded, and that is called as catalyst. So I would tell in commonly, if you consider example of rusting of iron, you all know rusting of iron, right? So rusting of iron process, so the chemical reaction takes a decays itself. It may takes around 20, 30 and so on years is needed to one iron get rusted. This is considered to be a very slow reaction. Whenever we make use of a catalyst in a chemical reactions, rate of reaction is going to be forwarded. One more thing, catalyst will be remained as it is as an inert molecule, and we can be gain it after the reaction. So I would define here catalyst. When you consider definition part of the catalyst, these are molecules which causes change in chemical reaction, that is nothing but it may enhance or it may stops the rate of the reaction. Generally what it does, in presence of catalyst, generally chemical reaction will be taken forward. So molecules which causes change in chemical reaction, generally forward reaction will take place without undergoing any change in its mass or chemical property is referred as catalyst, and it can be gained back after the completion of reaction. It is called as catalyst, right? So catalysts are molecules which causes chemical change in a reaction without undergoing any change in its mass or in its chemical property. It will be remained as inert molecule in a chemical reaction. I have written here one of the example for catalyst used reaction. Whenever we have potassium chlorate, initially conversion of potassium chlorate to potassium chloride and oxygen requires a large span of time. In order to make this reaction reduced time, in order to get the product within a short time, within the short period of time, we make use of catalyst. The catalyst in this reaction used is referred as manganese dioxide, MnO2. So it is referred as catalyst used reaction. Conversion of potassium chlorate to potassium chloride and oxygen can be carried out in presence of catalyst which is MnO2. So this is the reaction. You can expect the question catalyst with example. Then you are supposed to write this way. We need to understand two more terms for the catalyst process. They are referred as promoters and poison. Promoters promoters, PERS, and poison. So promoters are those molecules or chemical compounds which enhances the rate of catalyst. Catalyst itself, it enhances the rate of reaction, and these promoters further helps catalyst to make its activity in a speeder way, makes its action to be taken in a faster way. Promoters are those which enhances catalyst activity, which enhances catalyst activity. Now I have poison. One more term we need to understand regarding poison. I have told you, as name itself suggests, here these poison are molecules or chemical compounds which stops or which nullifies the or which inhibits the activity of catalyst. They are called as poison. These inhibit activity of catalyst. These inhibit activity of catalyst. So these are the two important terminologies we need to understand in case of catalyst. So very firstly we have defined what is catalyst and what is catalysis process, right? We have seen the example 2. Then we have seen there are two terminologies or two terms or chemicals involved in the catalyst. They are promoters and poison. Promoters are those which enhances the activity of catalyst. Poison are those which inhibits the activity of catalyst. So this is all about the brief introduction regarding catalysis process. For our syllabus, we need to understand in detail regarding shape selective catalyst. What do you mean by shape selective catalyst and the process shape selective catalysis? We need to understand in detail. Please do copy this one. We'll move to next part. Now let us understand regarding shape selective catalysis. We need to understand these 3 points. Before to that one, I just give you a clear explanation regarding shape selective catalysis. Shape selective, as name itself suggests, a particular shape of the catalyst is going to be preferred for binding of substrate molecules, or we can call them as reactant molecules. I'll tell you, I have catalyst of this shape. I have catalyst of this shape, like somehow flower shape. Now I need to fix reactant molecule or substrate molecule on this catalyst to perform catalysis reaction. So now see here, a substrate is having a spherical shape and one more substrate is present, that is of pentagon shape, and I also have one more substrate which is of again flower shape itself, right? So these are said to be, all the three are said to be reactant molecules, or they are said to be substrate molecules. REACTANT, reactant molecules, or we can call them as substrate molecules, which are very much selective in the shape of the catalyst. If this spherical type of substrate or reactant molecule is coming and attaching on this one, no, process is not going to take place because the shape of 2 is entirely different. So this is considered to be a catalyst. Now let us see second one. If this is coming and attaching, no, this reaction is also not possible because shape of the reactant molecule is different. Likewise, I have third option here. If it is coming and combining here, yes, it is possible because the shape of the reactant molecules or the substrate molecule as well as the shape of the catalyst is matching here. So this reaction is going to be feasible. Catalysis process is going to take place. This is nothing but shape selective catalysis. Shape of particular catalyst is going to be preferred for the same reactant molecules. They must also have same shape as that of the catalyst. So if you can consider this as a reactant molecules, substrate, as well you can consider enzyme. If the enzyme is coming, enzyme catalyzed reaction we can call. If the other molecules are coming, then simply we call catalysis reactions. Now I supposed to mention here regarding the pore size. the pore size of the catalyst and the reactant molecules or the enzyme molecules must match there, then only reaction is going to take place. Example for aluminosilicates, I have mentioned here bonding ALOSI. These are said to be aluminosilicates. Aluminosilicates, right? So these aluminosilicates linkage will be as the same as that of honeycomb type of linkage. Honeycomb you might have seen, no? It is small, like this pentagon type, like this honeycomb you might have seen. It will be existed in this fashion, like this, right? It is a network of such type of structure, I could tell. You might have seen the honeycomb. So aluminosilicates generally existed in a honeycomb structure, and shape selective reaction can be carried out with the aluminosilicates. It also involves pore size of catalyst as well as incoming reactant molecules. Now these are said to be microporous. Aluminosilicates are said to be microporous in nature. If you see the network of these structure, network type structure of aluminosilicates is as follows. So if you consider this is a silicon, it will be present at the center, right? Then you have this one oxygen, and it gets bind with another oxygen and silicon bonding, fine, and it will be like this, and so on it goes. Oxygen here also. Now you can see here you will have one more silicon, and this structure network of these oxygen and silicon is continued, and from this one you are going to remove aluminium. From the aluminium silicates structure, if you just go on removing the aluminium and you are combining 2 units of such, it will form a network of aluminosilicates which exactly resembles honeycomb structure. This is seen to be in a three-dimensional aluminosilicates structure will be considered as honeycomb structure, and it will be considered as example for shape selective catalysis because they resemble shape of honeycomb, on which catalysis process is going to take place, on which reactant molecules, substrate molecules or enzymes which are similar to that of the structure of honeycomb will go and attach, and the catalysis process carried out. For that, pore size is most important and shape is honeycomb shape. Example is microporous aluminosilicates which have small pores in them as well. They are honeycomb in nature. I have shown here linkage which is exactly similar to that of honeycomb structure. Three-dimensional aluminosilicates will be considered as examples for shape selective catalysis process. Three-dimensional view of aluminosilicates I have written here. It's a kind of linkage which is present in case of example of aluminosilicates, which are main example for shape selective catalysis. So please do copy this. I will tell you what are the applications of such type of catalysis reactions. Do copy this. So when you see applications part of shape selective catalysis or catalysis process, we would write here 2 applications. Used in the petrochemical industries for cracking of long chain carbon compounds. Long chain carbon compounds made of catenation processes are said to be very strong. In order to break the bond, we are supposed to provide higher energy. Along with that, we are going to use catalyst, which are shape selective or catalysis process can be carried out to break the bonds between the carbon atoms. So we generally use in petrochemical industries. Then second point, it is most important. Sometimes this question can be asked for 1 mark. ZSM-5 is a most prominent catalyst used for the direct conversion from alcohol to petrol gasoline. Conversion of alcohol to petrol gasoline is a kind of tricky reaction wherein we need a kind of catalyst which is referred as ZSM5. In your examination, they will ask you which catalyst is used for the conversion from alcohol to petrol gasoline. Then you are supposed to remember ZSM5 is the catalyst used. So once we complete this one, we are going to begin with the most interesting topic of the chapter surface chemistry, that is colloids. Please do copy this. We'll move to next part. Now let us understand regarding colloids. So what do you mean by exactly definition for colloids? Before I give you an exact pattern of the definition which is given in NCERT, I would like to give you one example, daily life example. ನೀವೆಲ್ಲರೂ ನೋಡಿರಬಹುದು, if you consider water one glass ಒಳಗೆ ಏನು ತಗೊಂಡಿರಿ, glass ಬಾಟಲ್ ಅಥವಾ ಗ್ಲಾಸ್ ತಗೊಂಡಿದ್ದೀರಿ ಅಂದ್ರೆ ಅದರೊಳಗೆ ಏನು ಹಾಕ್ತೀರಿ, ನೀವು ನೀರು ಹಾಕ್ತೀರಿ. ನೀರು ಹಾಕಿದ್ರ ಜೊತೆಗೆ ಏನು ಆಡ್ ಮಾಡ್ತೀರಿ, ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್, ಯು ಆಲ್ ನೋ ಕಾಮನ್ ಸಾಲ್ಟ್ ಆಡ್ ಮಾಡಿ ಏನು ಮಾಡ್ತೀರಿ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಅದನ್ನ ತಿರುಗಿಸ್ತೀರಿ. ತಿರುಗಿಸಿದಾಗ ಏನಾಗ್ತೈತಿ, do you see any salt is remaining at the bottom? No, you can't see because it is completely miscible in water. ಹೌದಾ, clear solution ಕಾಣಿಸ್ತೈತಿ. That also called as true solution. When you consider mixture of water and solute, that is sodium chloride, is completely dissolved, then it is said to be homogeneous mixture. Homogeneous mixture ಒಳಗ ಏನ್ ನಾವು solute add ಮಾಡಿರೋದನ್ನ ಆಮೇಲೆ solvent ಅನ್ನ separate ಆಗಿ ನೋಡ್ಲಿಕ್ಕೆ ಆಗಂಗಿಲ್ಲ. ಎರಡು ಕಂಪ್ಲೀಟ್ ಮಿಕ್ಸ್ ಆಗಿ they seems to be like a water itself, but we all know as we have added solute particles are also present in that one. That is called as homogeneous. Homo ಅಂದ್ರೆ ಸೇಮ್, ಎರಡು ಏನಾಗ್ತಾವು ಮಿಕ್ಸ್ ಆಗಿ ವಾಟರ್ ತರಾನೇ ಕಾಣಿಸ್ತಾವು, ಬಟ್ ಸಾಲ್ಟ್ ಇದೆ ಅನ್ನೋದು ಕೂಡ ನಮ್ಗೆ ಗೊತ್ತಿರ್ತೈತಿ. They are called as homogeneous. Okay, I will give you one more type of solution, that is heterogeneous solution. Right, heterogeneous solution ಅಂದ್ರೆ ಏನ್ ನೋಡ್ರಿ, say for example one glass ಒಳಗೆ ಏನು ತಗೊಂಡ್ರಿ, water you have taken. To that you are going to add turmeric powder. You all know ಅರಿಶಿಣ ಪುಡಿ ಆಡ್ ಮಾಡ್ತೀರಿ. ಆಡ್ ಮಾಡಿ ಕಂಪ್ಲೀಟ್ ಅದನ್ನ ಶೇಕ್ ಮಾಡ್ರಿ. ಶೇಕ್ ಮಾಡಿದಾಗ do you see color or no? Yes, you will see, no? So ಆ ತರ ಕಲರ್ ನಮಗೆ ಸೆಪರೇಟ್ ಆಗಿ ಕಾಣಿಸ್ಲಿಕ್ಕತ್ತಿದ್ರ that is called as heterogeneous mixture. ಅದರೊಳಗ ಸೆಪರೇಟ್ ಆಗಿ ಕಲರ್ ಕಾಣಿಸ್ತೈತಿ. ಟು ದ ಲಾರ್ಜರ್ ಎಕ್ಸ್ಟೆಂಟ್ ಟರ್ಮರಿಕ್ ಪೌಡರ್ at the bottom ಸೆಟಲ್ ಆಗಿರೋದು ಕೂಡ ನಮಗೆ ಕಾಣಿಸ್ತೈತಿ. They are said to be not true solutions. They are said to be heterogeneous mixtures. Homogeneous mixture ಒಳಗ ಸಾಲ್ಟ್ ವಾಟರ್ ಎರಡು ಮಿಕ್ಸ್ ಅಪ್ ಆಗಿ ವಾಟರ್ ತರಾನೇ ಕಾಣಿಸ್ತೈತಿ. ಹಿಟ್ರೋಜಿನಿಯಸ್ ಒಳಗ ಕೆಳಗೆ ಏನಾಗಿರ್ತೈತಿ, ಸೆಟ್ಲ್ ಆಗಿರ್ತೈತಿ. ಆಡ್ ಮಾಡಿರುವಂತ ಸೊಲ್ಯೂಟ್ ಪಾರ್ಟಿಕಲ್ಸ್ ಕೆಳಗಡೆ ಸೆಟ್ಲ್ ಆಗಿರ್ತಾವ. ಆಮೇಲೆ ಅದ್ರ ಜೊತೆಗೆ ವಾಟರ್ ಕೂಡ ಎಕ್ಸಿಸ್ಟ್ ಇರ್ತೈತಿ. ಬಟ್ ವಿ ಕ್ಯಾನ್ ಸಿ ದ ಚೇಂಜ್, ದಟ್ ಈಸ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದ ಸೊಲ್ಯೂಟ್ and difference between the solvent. Solute solvent between in the difference ಏನಾಗ್ತಿರ್ತೈತಿ ನಮ್ಗೆ ಕ್ಲಿಯರ್ ಆಗಿ ಕಾಣಿಸ್ತಿರ್ತೈತಿ. ಅದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು heterogeneous mixture ಅಂತ ಹೇಳ್ತೀವಿ. Right. Similarly, now come to here regarding colloids. Colloids are also referred as heterogeneous mixtures. They are referred as heterogeneous mixtures. Heterogeneous mixtures ಅನ್ನ ಏನಂತ ಹೆಸರಿಟ್ಟಾರ ಅವರು, dispersed phase and dispersion medium. Here they also have mentioned the particle size. I will tell you first what do you mean by dispersed phase and dispersion medium. As I told you, true solution. Example I had given, no, true solution. Lean tondidvi water and salt. We can call water as solvent. Howdallo solvent anta kariboda. Amele in tondidvi we had taken salt. NaCl we had taken. Can we call it as a solute? Right? Can we call it as solute? This is in case of solution. Now, in terms of colloids, if you would like to talk, then dispersed phase is nothing but solute itself. Solute itself is referred as dispersed phase, whereas solvent is referred as dispersion medium. Solvent is referred as dispersion medium. Okay? So we all know, ಇವಾಗ ನಾನು ಹೇಳ್ರಿ dispersion medium large ಇರ್ತದೋ ಅಥವಾ ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಲಾರ್ಜ್ ಇರ್ತದೋ, ಕ್ವಾಂಟಿಟಿ ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್ ಯು. ಯಾವಾಗಲೂ ಲಾರ್ಜ್ ಅಮೌಂಟ್ ಆಫ್ ವಾಟರ್ ಒಳಗೆ ಏನು ಆಡ್ ಮಾಡ್ತೀವಿ, ಸ್ಮಾಲ್ ಅಮೌಂಟ್ ಆಫ್ ಸೋಡಿಯಂ ಕ್ಲೋರೈಡ್ ವಿ ವಿಲ್ ಆಡ್ ಅಂಡ್ ವಿ ವಿಲ್ ಶೇಕ್ ಇಟ್ ಅಂಡ್ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಮಿಕ್ಸ್, ರೈಟ್? Similarly, always do remember dispersion medium is larger, dispersed phase is considered to be smaller. Now particle size they have mentioned here. Particle size from 1 to 1000 nanometer if it is there, then it is referred as colloid. It is referred as colloid. Colloid olaga particle size ಏನು ಇರ್ತೈತಿ, 1 to 1000 nanometer. If it is exceeding 1000 nanometer, 1000 nanometer ಗಿಂತ ಜಾಸ್ತಿ ಇದ್ರ, 1 to 1000 nanometer ಗಿಂತ ಕಡಿಮೆ ಇದ್ರ, what I have written here, no, it is less. Okay, 1 to 1000 nanometer ಗಿಂತ ಕಡಿಮೆ ಇದ್ರ, then it is referred as true solution. True solution ಒಳಗ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ, ಡಿಸ್ಪರ್ಸ್ಡ್ ಫೇಸ್ ಅಂದ್ರೆ ಸೊಲ್ಯೂಟ್ ಸಾಲ್ವೆಂಟ್ ಬಿಟ್ವೀನ್ ಯಾವುದೇ ರೀತಿ ಏನಿರಂಗಿಲ್ಲ, ಡಿಫ್ರೆನ್ಸ್ ಇರಂಗಿಲ್ಲ, ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮಿಕ್ಸ್ಅಪ್ ಆಗ್ಬಿಟ್ಟಿರ್ತಾವ. ಅದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು, ಟ್ರೂ ಸೊಲ್ಯೂಷನ್ ಅಂತೀವಿ. ಅಲ್ಲಿ ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಏನಿರ್ತೈತಿ, 1 to 1000 nanometer ಗಿಂತಲೂ ಕಡಿಮೆ ಇರ್ತೈತಿ, ಹೌದಾ? ನೆಕ್ಸ್ಟ್ ಏನೈತಿ, ಕೊಲಾಯ್ಡ್. ಕೊಲಾಯ್ಡ್ಸ್ ಒಳಗ ಕಂಪಲ್ಸರಿ 1 to 1000 nanometer ಪಾರ್ಟಿಕಲ್ ಸೈಜ್ ಇರಲೇಬೇಕು. ಅವಾಗ ಮಾತ್ರ ಅದಕ್ಕೆ ಏನಂತೀವಿ ನಾವು, ಕೊಲಾಯ್ಡ್ ಅಂತೀವಿ. ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ, ಇಲ್ಲಿ 1 to 1000 nanometer ಗಿಂತ ಸೈಜ್ ಜಾಸ್ತಿ ಇತ್ತಂದ್ರ, ಇಫ್ ಇಟ್ ಈಸ್ ಸೈಜ್ ಮೋರ್, then we can call them as suspensions. We call them as suspensions. Suspension ನೋಡಿರಿಲ್ಲ ನೀವು, ಇವಾಗ ಕೆಮ್ಮದು ಬಂದಿರ್ತೈತೆ ಅಥವಾ ಏನೋ ಇರ್ತೈತೆ, ಅವಾಗ ನಮ್ಗೆ ಏನ್ ಕೊಟ್ಟಿರ್ತಾರ, ಸಿರಪ್ ಕೊಟ್ಟಿರ್ತಾರ, ರೈಟ್? ಸಿರಪ್ ಅನ್ನ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಸಣ್ಣದ ಲೀಡ್ ಒಳಗೆ ಹಾಕೊಂಡು 10 ml 5 ml ಎಷ್ಟು ಹೇಳಿರ್ತಾರ ಅಷ್ಟು ಕುಡಿತೀವಲ್ಲ, that is called as what? Suspension. Particle size, if it is more than 1 to 1000, suspension. If it is 1 to 1000 less ಇತ್ತಂದ್ರ true solution. 1 to 1000 nanometer ಒಳಗ ಆ ರೇಂಜ್ ಒಳಗ ಲೈ ಆಗತ್ತಿತ್ತಂದ್ರ that is called as colloids. So colloids are heterogeneous mixtures of dispersed phase and dispersion medium with a particle size 1 to 1000 nanometer. So here for this colloids we have lot of examples. We can mix solid gas, solid liquid, solid solid. We can mix in a numerous way. We will understand how does dispersed phase and dispersion medium together they will mix up, and we will be getting a fresh final example for colloids. We will understand that one. Before to that, please do copy this, and it is said to be most important. You have to remember these terminologies, and this value 1 to 1000 nanometer is the most important particle size you have to remember. On this, you can expect question for your competitive examinations. Particle size, on the basis of that one, you can expect a question. And this is how brief introduction for the colloids. Now we'll see how does colloids have been classified. Please do copy. We'll move to next. Now let us understand regarding the classification part of colloids. So as I told you, there are two phases are involved. One is dispersed phase and one is dispersion medium. Sorry, dispersion phase and dispersion medium are involved, not two phases. It is heterogeneous, in which we will be having dispersed phase and dispersion medium. Now based on physical state of dispersion phase and dispersion medium, we have certain classifications here. So dp indicates it is said to be dispersed phase, dm indicates it is said to be dispersion medium. Dispersed phase and dispersion medium together we will be naming the particular colloid here. So when you consider solid dispersed phase and solid dispersion medium, we can call them as solid salts. We call them as solid salts. Similarly, solid and liquid together they combine, then it is called as salt. Just it is very simple. Remember, these are most important. Based on this, definitely 1 mark question can be asked. So do concentrate and listen to me properly and understand the things very well, and then write in the points. See here, solid we call it as solid salt. SS solid salt. Solid liquid we have sol. SL sol we can write. Solid, gas we have. Gas is involved in solid. We call them as aerosols. Aerosols. Just remember these things. Next, they will be remembered with a trick I will tell you. Here we have liquid in solid. We have dispersed phase. So these are small quantity. These will be considered as solutes, and dispersed phase in terms of colloids. So these are said to be in smaller quantity, and these are said to be in higher quantity, larger quantity. Okay, so liquid is dissolved in particularly solid, then it is said to be gel. Liquid combination, it is called as emulsion. Liquid gas combination, it is called as aerosol. Gas and solid combination, it is called as solid sol. Solid sol, we have solid sol. Solid also has given solid sol. And gas solid also have given solid sol, because this dispersion medium is in higher range. Then we have gas and liquid combination. It is called as foam. Just remember these three. To remember these, we have one trick we can say here. GASF. GEASF. You can remember GASF. If you just remember this GASF phrase, you go on remembering the examples or names of the colloids for particularly combination of these two. With the examples I have written, the things will become more clear for you. So first one, it is said to be solid solid. Solid sol we have written here. Mixing of solid in solid itself is referred as solid sol. Example is gems which are colored in nature. Colored gems. They are made of solid of two particles, and they will give us colored particles. Then we have solid mixed in liquid. Dispersion medium is said to be highest one, in which smaller solid particles dissolved in liquid, then they are said to be sol. And the example are paints. Paints are made of solid liquid. They will be called as sols. Then we have solid dissolved in gas. They are called as aerosol. Dispersion medium is large one, so we call them as aerosols. Aerosols, if you consider example, smoke, dust, right? Dust particles are considered to be solid, and the atmosphere in which many gases are present, they are said to be dispersion medium, in which solid particles are present. So smoke, dust are the examples. Similarly, I have liquid dissolved in solid. Then it is called as gel. Liquid dissolved in solid, it is called as gel. Cheese, butter, jelly, these all examples you might have seen. Similarly, liquid dissolved in liquid, then they are called as emulsions. Emulsions in the sense milk and water generally mixed, and also hair cream what we apply, they are also example for emulsions. And from here, GASF, if you just remember GEASF, these are the colloids which are example for respective DP and DM. Now see here, liquid dissolved in gas, they are called as aerosols. They are called as aerosols. Fog, cloud. Cloud all are said to be liquid form, but they exist in atmosphere. We can quote as an example for aerosols. Similarly, gas dissolved in solid. Now the trick equation has applied here. We call them as solid sols. What are the examples? Foam, rubber. Rubber initially it is in the form of like solid. On continuous supplying of high gas or high pressure, it will be converted into solid form. So solid sol. Next we have example, gas dissolved in liquid. The example is foam. Foam, gas. Foam is one of the form of colloid itself. So these all are the names of the colloids on the combination of DP and DM they have obtained, and respectively I have these examples. So gas dissolved in liquid is the example of froth and wiped cream. What we had taken, we initially wiped the cream in the sense we will be having continuous mixture. We will be adding certain things in the mixture. Foaming will be coming there. In the liquid phase, liquid ಈಗ ನೋಡ್ರಿ ಒಂದು ಬಕೆಟ್ ತಗೊಂಡಿರ್ತೀರಿ, ಬಕೆಟ್ ಒಳಗೆ ಏನು ಮಾಡ್ತೀರಿ, ಇಷ್ಟೇ ನೀವು ಡಿಟರ್ಜೆಂಟ್ ಪೌಡರ್ ಹಾಕ್ತೀರಿ, ಶೇಕ್ ಮಾಡ್ತೀರಿ, ಏನು ನೊರೆ ಬರಲ್ಲ. ಜಾಸ್ತಿ ಹಾಕಿದ್ರಿ ಶೇಕ್ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಕೈನ ರೊಟೇಟ್ ಮಾಡಿ ಶೇಕ್ ಮಾಡಿದ್ರೆ ಅಲ್ಲಿ ಏನಾಗ್ತೈತಿ, ಕಂಪ್ಲೀಟ್ ಇಲ್ಲೇ ಫೋಮ್ ಬರ್ತೈತಿ, ಫ್ರೋತ್ ಬರ್ತೈತಿ, ಮೇಲ್ಗಡೆ ಏನಂತಂದ್ರೆ ಬುರುಗ್ ಬರ್ತೈತಿ. ಆ ಬುರುಗ್ ಎಕ್ಸಿಸ್ಟ್ ಇರೋದು ಗ್ಯಾಸಿಯಸ್, ಬಟ್ ಯಾವ್ದ್ರೊಳಗೆ ಎಕ್ಸಿಸ್ಟ್ ಐತಿ? ಲಿಕ್ವಿಡ್. ವಾಟರ್ ಮೇಲ್ ಫ್ರೋತ್ ಬರ್ತೈತಿ ಇಲ್ಲ. ಸೊ ಗ್ಯಾಸ್ is a solute present in liquid is the example. So this classification is mainly based on physical state of dispersion medium and dispersion phase and dispersion medium. Always remember these examples. Idan ನೆನಪಿಟ್ಕೊಳ್ಳೋದು ಬಹಳ ಈಸಿ ಐತಿ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ಬಿಡ್ಬೇಕು? ಸಾಲಿಡ್, ಲಿಕ್ವಿಡ್, ಗ್ಯಾಸ್. ಆಮೇಲೆ ಗ್ಯಾಸ್ ಎಕ್ಸಿಸ್ಟ್ ಇರಂಗಿಲ್ಲ. they nowhere going to be existed. ಆ ಎಕ್ಸಾಂಪಲ್ ನಿಮಗಿಲ್ಲ ಅಂತ ತಲೆ ಕೆಡಿಸ್ಕೋಬೇಡ್ರಿ. ಬಟ್ ಡಿಸ್ಪರ್ಷನ್ ಮೀಡಿಯಂ ಸಾಲಿಡ್ ಲಿಕ್ವಿಡ್ ಇದೇ ತರ ಈ ಪ್ಯಾಟರ್ನ್ ಒಳಗನ ಏನ್ ಮಾಡ್ಬೇಕು? ನೆನ್ಪಿಟ್ಕೋಬೇಕು. once you are able to write this pattern and able to write this pattern, remembering these things are very easy. once you conclude ಅಂದ್ರೆ ಯಾವ ಕೊಲಾಯ್ಡ್ ಅನ್ನೋದು ನಿಮ್ಗೆ ಗೊತ್ತಾಯ್ತು ಅಂದ್ರೆ examples are said to be very much easiest. Understood? Please do copy this. We'll move to next. Now let us understand classification of colloids based on nature of interaction. So in this case, if you consider, they have been classified into two categories. One is lyophilic colloids and the other one is lyophobic colloids. Philic, you have seen generally in organic chemistry we prefer for electrophilic, we can call. Electrophilic in the sense, philic in the sense loving, and here lyo in the sense solvent loving. If you consider water, they will be very easily dissolved in water, then they are very love with water. So they are called as lyophilic. So if the solvent you consider water, then it is called as hydrophilic. Okay, if the solvent you consider alcohol, the substances which are very easily feasible or they are very easily dissolved in alcohol, then they are called as alcophilic. Fine, this is the example I have given you. Now I have two types, lyophilic colloids and lyophobic colloids. Exactly opposite to lyophilic, we have lyophobic colloids. They are solvent hating. They do not easily get dissolved in solvents. They are called as lyophobic. Phobia in the sense a kind of fear or being inert, remaining outside from the solvent. They are called as phobic, lyophobic colloids. Right? Now, if you consider lyophilic colloids, I have example gum, gelatin, starch and rubber. If you shake any lyophilic kind of colloids, if you shake them properly, then they are going to be reversed back. They will be reversed in nature. Reversibility is possible. And the last point, if you consider lyophilic type of colloids are considered to be a most stable type of colloids. Likewise, I have example for lyophobic colloids. If you consider lyophobic, sulfide and solvent, if you consider, they remain separately in the mixture. They are called as lyophobic colloids. They do not get dissolved easily in any solvent taken. Then they are coagulated. I'll tell you, explain these things in detail. Coagulation is a kind of like thickening of the layer. If you have any hurt on a skin, bleeding of the blood will be taking place. In order to patch up that one, we will be using certain ointments and all. After applying that one, the blood will be coagulated, right? That process is called as coagulation. So here, if you consider lyophobic colloids, they are going to be easily coagulated, right? Then they are not so stable in solvent condition, and for that reason we need stabilizing agents. We need to add stabilizing agents to make the colloids stable. So these are the two types of colloids which have been classified mainly based on nature of interaction. So 3 points I have covered for each as with the example also. Please do copy this. We'll move to next part. Now let us understand next type of classification, that is classification based on particle of dispersed phase. Particle of dispersed phase in the sense generally we consider small part, that is dispersed phase. which is considered to be a solute which is smaller in range than that of dispersion medium. We have three main categories in case of dispersed phase size. That is solute size. Based on solute size, we have categorized into three types. Very first one, it is said to be multimolecular colloids. Multimolecular in the sense we can write here that these are formed due to association of small molecules of less size. Size is less than 1 nanometer. Multimolecular in the sense small molecules will combine each other, and those combining molecules, I repeating my words, those combining molecules will be having size less than that of the colloids. That is less than 1 nanometer. They are called as multimolecular type of colloids. Here combining molecules will be having size less than that of colloid size. So example S8, sulfur atoms combine each other, they will form a network of S8. S, there is a combination like that. 8 sulfur atoms combine each other, they will be coming at last in the colloidal range. Before to colloidal range, they are having size less than that of the colloidal range. And the other example I have written here, it is gold, right? Then I have macromolecular colloids. So these molecules or macromolecular type of colloids are obtained or classified mainly on the basis of, these are formed due to dissolving of macromolecules into suitable solvents. Okay. So macromolecules in the sense they will be a complex polymers. We have seen in the polymers chapter regarding the enzymes, proteins, nucleic acids and so on. Right? So those macromolecules are going to be dissolved in a respective or suitable solvent to make that whole mixture in a colloidal range. We will be taking that to the colloidal range. What is the colloidal range? 1 to 1000 nanometer. Macromolecules will be having size bigger than that of the colloidal range. After they are get dissolved in the suitable reagent or the suitable solvent, they will be coming near or they will be coming under the range of colloid. So macromolecules like starch, cellulose, enzymes, proteins are going to be added in the solvents and they made to colloidal range. So such type of classification is called as macromolecular colloids, right? Then I have associated. For this I need to explain you with the example. I have one solvent added with particular substance. Then it is said to be a simple solvent. This is a solvent having these molecules are less than that of the colloidal range size. Fine. So for such a solvent, if you just add any particular substance, if you just add any particular substance, the molecules which are rotating or which are existed far away, they start coming each other. They start coming near to each other and they will associate in this fashion. This association of molecules makes colloidal range. Association makes colloidal range 1 to 1000 nanometer, right? When after association itself, these molecules will be coming under the range of colloid, that is 1 to 1000 nanometer. So I could tell here that under low concentration, substance is already present here, but in a lower concentration. In lower concentration, it will be just acting as a strong electrolyte. But after adding a suitable substance, it will be acting as a colloid. We also call it as micelle. I'll explain micelle in detail. Higher concentration, that is substance is added in excess, then association of small atoms together, they will form a molecule which will be having a range of 1 to 1000 nanometer. So it is called as colloid or a micelle. But in lower concentration, this is just will be acting as an electrolyte, strong electrolyte. After adding a suitable substance, it will be acting as particularly colloid. So this is the classification based on size of dispersed phase. I hope this is clearly understood to you. If you really like this video, please do like the video, share and please do subscribe. Before that, please do copy this. We'll move to next part.